All right, thank you all for coming. It's really great to see you. My name is Vin Sharma. I'm a strategist at Intel for software. I work at the intersection of open source software, big data analytics, and cloud computing, which if you kind of put those three together is a pretty large set, but it's a lot of overlap. And for the past year and a half, I've been looking at ways in which Intel could participate in this ecosystem by driving innovation faster through the community, both in the open source as well as in the enterprise adoption of Hadoop. And that kind of is where we've focused, for the most part, our attention as a company, as an organization. And it led us about a year and a half, almost 2 years now, to the notion that one of the things that would drive enterprise adoption of Hadoop at scale and would drive more value from the data that's being collected or not being collected by many organizations is if Hadoop as a platform were more robust, more secure, and more scalable. But a number of those efforts are already underway in the community. There's certainly no reason for us to kind of jump in as Superman, but there was certainly a reason for us to focus on certain things that seemed like hard problems that the community needed some amount of bootstrapping and leadership to get started around. And security was one that we picked up as a strong interest for Intel. It's a historical interest. We obviously have had a number of software acquisitions to support that effort, but also just broadly speaking, security is one of the pillars for Intel's involvement in any project, and this is a good case of good reason for us to be involved in it. When we started to look at it, there was a fair bit of, I'll say, static friction in the community about the need for security, in large part because there's still hard problems of Hadoop deployment, of performance, and things like that. And a lot of people weren't ready to even grapple with the issues and challenges of security. But as we went out and talked to customers, primarily in vertical industries like financial services and healthcare, we found that there was a pent-up demand for a more robust security framework around Hadoop because, face it, if you're a healthcare business or your organization, there's a fair bit of data that you have up until recently held within a data protection regime that has good, strong controls that are auditable, and it's necessary. And it's not just necessary, but you are held accountable through regulations that you must comply with. And in order for Hadoop to make its way into that kind of a regime, into that part of the data center, it too must support those compliance regulations, or must support those regulations and allow you to be compliant with the data sets that even as you move them onto Hadoop, you remain compliant. So the challenge fundamentally is that Hadoop as a technology has enormous potential to help you make sense of a lot more data than you were previously able to. It's specifically the case with high data growth industries such as healthcare and financial services, where the value is even greater, to be able to do more with the analysis of the data than you were previously able to. But in order to address that challenge, you need to have Hadoop itself have security from within and from without, and have all of that platform, that data platform, under a common data protection regime or data governance regime. So if that is the problem, then Intel's role in it becomes a lot clearer, and for us, that path forward was to work within the open source community, do a lot of the work upstream, and make that available to any platform that builds around it. And so it's not specifically limited to selling one particular product, although obviously to the extent that we're able to take advantage of Intel Xeon processors and the features that are built into the Xeon processors, everybody benefits, and it's a common standard platform. So if you look at the way healthcare typically addresses the data needs and the analysis problems, there's an enormous potential here just in terms of the value that could be derived from processing the data. You look at the number of participants, whether it's a provider, a patient, a payer in some cases that's different from the patient. There's a fair bit of work that happens in life sciences that's related to big data, specifically the analysis of very diverse data sets in such a way that together the analysis of that data and the correlation and the conjoining of these multiple data sets brings forward data-driven discovery and accelerates the process of discovery for everything from pharmaceuticals to just even hospital processes, as we're discovering. So if you recognize yourself as a business that is in this space, I mean, at the end of the day, you can generalize that and say it's true for healthcare and it's true for financial services, which are both highly regulated industries. But as an enterprise, as any organization, you're likely to have interest within any of these elements in the spectrum, right? So and if you put that together for healthcare specifically, we know from various studies, very specifically the McKinsey Global Institute study, that there's a $450 billion savings that's available from the use of big data analytics in the healthcare industry alone. And if you then said, you know, what is the potential for financial services or for, you know, manufacturing, the value compounds. And so our assumption and our working model is that if you can derive this level of benefit from applying big data analytics at different stages of this process, then every one of these participants in this cycle benefits an enormous amount. And we think security is a key mover, a technical issue in this space, that if we were to push that boulder out of the way, the adoption of big data analytics in these industries would accelerate and the value would be unlocked. So that's sort of the premise. So what are those specific compliance challenges, right? So if you look at the HIPAA regulation in particular for the healthcare industry, and for other industries there are different regulations. The ones that jump right out and speak specifically to the technology that we're talking about are the privacy rule and the security rule. And I'm going to focus on the security rule. In particular, there are three parts to the security rule. There's the administrative safeguards, there are physical safeguards, and technical safeguards. They mean exactly what they say. So administrative safeguards have to do with the process and the organizational structures that you put in place in order to make sure that the data remains protected and the privacy of the data is safeguarded. The physical safeguards have to do with the way you have security detail. I mean, literally the way that the data center is protected by security guards and by, you know, monitoring systems and video surveillance cameras and so on and so forth. Interesting, but not directly relevant to Hadoop. The one that catches our interest are the technical safeguards. So let's look at those. The technical safeguards break down into four categories. There's access controls, audit controls, integrity controls, and transmission security. And again, somewhat self-evident, but the first one has to do with the fact that a covered entity, and in this case that means a business or an organization, and in the case of AWS, that would mean a contractually partnered, you know, business associate that is looking to take advantage of the AWS infrastructure to deliver a medical application that remains in HIPAA compliance, would be somebody that needs to have technical policies and procedures that allow for essentially role-based access control to the healthcare information, to the health information. Audit controls, again, it's very clearly that any kind of creation, update, read, delete, access to the data sets that is being held in this Hadoop data management platform are audited and can be traced back to the origin of the change and to the identity of the person that made the change. Right? Integrity controls, very commonsensical notion that any change at all to the data is done with the right authorizations and that you're not, you know, losing confidentiality or the integrity or the authenticity of the data as it's being, as it's flowing through from the ingest through the analysis phases. And particularly speaking to that flowing through, if there are various components and various interoperable parts in your deployment, if it's a Hadoop cluster talking to, say, an SAP HANA system, and you've got a database, a transactional database somewhere else, and they're all related to this application that you've built, then the data as it's moving across these parts and within the cluster remains secure. So encryption of data at rest, as well as data in motion, is, for example, one way in which you would ensure that transmission security. So great, so these are the set of requirements we're working with. We understand that there's a lot of industries that must have big data applications that are in compliance with regulations. Those regulations spell out very clearly what rules to follow, and now you have to deliver to those requirements the platform that can support those rules so you can be in compliance. Well, what do you make of Hadoop? So when we started this, and this was 2 years ago roughly, this is kind of how we saw the landscape of Hadoop projects. There's a lot of interoperating components. They're loosely coupled, and each project has a team that focuses on their requirements, and they go off in a sort of quasi-independent direction depending on the priorities that they have. Well, that's nice, but how do you get some kind of a consistency across this, right? So these are the components that have a common authentication framework. Focus on the ones that are in blue. The white ones are the ones that don't, right? So the ones in the lighter shade color do not have the common authentication framework. These are the components that have a common access control framework. These are the components that are able to do admission control. And these are the components that we saw were capable of transparent encryption. These were the components that had a common policy engine. These were the ones that had a common audit log format. So that was it. That was kind of the landscape that we started with 2 years ago, and we felt, well, this is great. Hadoop is wonderful, but it's not. I mean, although we would all like to think it's the best thing since sliced bread, there's some work to get it, toasted, if you will. And our approach was very careful. So first off, we didn't want to do bolt-on security. We didn't think that that was the right way to go about creating a special layer or a proprietary component that would, be the single arbiter for all security access and control into the Hadoop data platform. So we had to work first. The first principle was we had to work within the open source community, and second, that it would be something that we would build into the platform, much as if any of you are familiar with trusted operating systems from back when. The approach there is to kind of start with the notion that you have system calls and library routines and commands, and every one of them has to be underpinned by a common security framework. It applies to the file system, it applies to process management, memory management, and so on and so forth. So if you do truly believe that Hadoop is the operating system for the data that will hold eventually everything that an organization considers valuable, and it's the data reservoir or the data lake or the data repository, and if it is the data operating system, then there should be a trusted operating system style of security development for it. And to us, that meant a number of different things, and we brought those things together under a common umbrella project that we called Rhino, for obvious animal reference reasons. So hardening that Hadoop from within to us meant that building what looked like a number of different component advances and optimizations, and not any one particular thing. So Rhino is not, say, like Project Sentry, a separate project, or Spark or Shark or something like that. It's not a separate Apache incubated project. It is a set of initiatives that we pull together because they affect everything from HDFS to MapReduce to Hive to Pig, HBase, and so on. And there's all sets of different changes, but we kind of wanted to have a common philosophy that drives them all. So the focus areas for us primarily were, first off, let's address the encryption issue, because if we can do that, then it can support a number of different things across the security of the platform. Second was role-based access control, again, for self-evident reasons. If you can get authorization, if you can get a common authorization framework for all the components, and you can allow for individuals or groups of users to have differentiated access to the data, that would be a key problem to solve, and we can then go forward from there. And finally, auditing. Again, it's critical that in order to be in compliance, you can trace back the changes that were made throughout the life cycle of the data. And so having a common audit framework was pretty key. So at the end of the day, we saw, again, as I said earlier, this Hadoop effort, the Hadoop security effort, as one akin to building a trusted operating system with layers of defense starting from the outside going all the way in to where even the containment of various or relative isolation of various Hadoop clusters within a common infrastructure. So as enterprises and clouds, as a cloud infrastructure such as AWS supports multiple tenants and quite possibly multiple organizations within each tenant, and each want to have a shared infrastructure, but very different in isolated clusters. You want to be able to support that as well. So to us, it meant it's not just the soft, chewy, center encased in some kind of a hard shell of a firewall. It was security throughout the various layers. So firewall through the gateway, through the authentication, authorization layers, encryption, as well as auditing and alerts. So let's start for the first one at the outermost shell. So ignore the firewall, that's pretty straightforward. When it comes to protecting the Hadoop APIs, we've noticed that there are several open APIs that allow you access directly to the HDFS file system, allow you access to MapReduce functions, and those APIs are, in many ways, an open door. Even if you were to protect against user access to the Hadoop cluster through the standard means, the APIs themselves need to be protected. And we could have, again, there is a project underway within the Apache Hadoop community that addresses some of these capabilities, but Intel for the past 12 years has been building and delivering a API gateway product that runs as an appliance or as a soft appliance or essentially as a software download into your infrastructure that is Common Criteria certified, the AL4 assurance level, FIP certified, and it seemed like a very natural fit to have in front of the Hadoop APIs to protect them. It's a great place in which to enforce common security policies across the Hadoop cluster. So all accesses inbound and outbound are governed by a common security policy. So that's interesting, but let's sort of keep peeling the onion, right? So the next layer down is role-based access control. And to us, a lot of the work here, particularly of late, in the recent 6 months or so, we've focused on H-based security, and we've taken a lot of inputs from customers as well as the community itself. There's obviously, and many of you probably know this, there's a lot of interest in Accumulo, Apache Accumulo, and there's a very granular access control built into that data store. And we wanted to make sure, first off, HBase is the columnar data store project that we at Intel decided to sort of build a lot of optimizations around, again, because of the early adopters and the customers that we've worked with. And it's part of that effort, we wanted to build in cell-level granular access control into HBase. And the way we've done this today is to use the standard access controller coprocessor that sits within HBase today, but to extend it to support cell-level access control. So up until now, it's been column family and table, but I think what we wanted to do is to extend it non-invasively to support cell-level access control as well. And so what you're seeing is a very elegant way to sort of deliver this today without making a lot of changes. And we wanted to sort of make that available. And it's, again, all of this code is in open source, and there was a reference to a Jira there that you could build upon. Let's look at encryption, because this was one of the first and the hardest problems that we had to solve. Again, our approach was to extend the existing framework. When we started to work with Hadoop, there wasn't really any encryption at all supported in the framework. There wasn't a shared framework for encryption. But there was one for compression. And so the design pattern for compressing a file and decompressing a file is very similar to that of encrypting a file and decrypting the file. So you encrypt the file when you store it to HDFS, and you decrypt it when you read it, you process it, and then you store it back again. There's one exception, which is that you need the key information before you can decrypt the file, and you need a key information to save it, so you need some amount of context and initialization support in addition to what you would typically do for compression. So Intel's approach was, again, to sort of build on the compression codec and extend it into a crypto codec, and the crypto codec uses some of the same API lineage, if you will, of the compression codec, but it works with the keys and the key store, the Java key store, and you can sort of integrate it with an external key management PKI infrastructure if you wanted to. So it's sort of, again, a simple but scalable solution for a number of different things. So if you can do that for HDFS, which we did, you can then move forward and start to enable this for other things in the ecosystem, HBase, and next I'll talk a little bit about Pig and Hive as well. So for HBase, again, there are two things. We wanted to have encryption support in addition to the cell level access control that I mentioned earlier, because even though there's a pretty solid protection of access control of the data that's in the cell, what if you decommissioned your cluster or particular nodes in the cluster and there wasn't a really good business process of erasing the data, and you still had the H files, the native files on HDFS that supported the HBase tables, but those were sitting somewhere. There's still a way to get at those raw files, and so we wanted to protect against accidental disclosure of or leakage of the information. And the way you do that is through encrypting the H files, the files underpinning the HBase tables themselves. So far, excuse me, a lot of this has to do with being able to encrypt the data under HBase, being able to do this for HDFS. But the next layer up, the next focus was really to go up the stack. So if you kind of say, well, encryption's HDFS is great, I can use a standard Java API to invoke the crypto functions, and now I can read and write the files in HDFS directly, and they're all, they're splittable. They can separate out, and you can kind of break the blocks across various nodes and still have the crypto functions, all good. But a lot of the development around Hadoop and MapReduce in particular is moving to higher and higher orders of abstraction to where you aren't directly invoking the MapReduce APIs as much as you're writing Pig scripts or using Hive queries to access the data, which means then that those encryption facilities must be exposed further up the stack. And the way we've been doing that is today now to focus on Avro file format encryption. So there's a certain amount of that built in, but we also have support for load and store functions in Pig to be encrypted, to essentially call the MapReduce and transfer the key information, get that into the hands of MapReduce so it can do the processing. Talked a little bit about how we delivered this. This is sort of the crypto codec for changes that we made, and it forms the basis. It's sort of the foundation for a whole range of extensible changes into the Hadoop ecosystem, right? Don't worry about trying to catch the code. It's all in a Jira. It's open source. You can download it from GitHub today if you wanted to. And we did work a fair bit on making sure that the key distribution, which is the second half of that encryption capability, being able to support that in integration in an enterprise is delivered. So all of this entirely in software, and you were starting to think, well, I thought Intel was a chip company and you sold processors, and you've talked mostly about the software optimizations and enablement of Hadoop as a data management layer with security built into it. A large part of the trade-off we saw organizations in healthcare or elsewhere do was between security and performance. There was a concern that the more security you added, one way or the other, the less usable the platform would be, and certainly less performant the platform would be. So in order to make sure that the advances in security that we were building into the platform did not compromise the performance of Hadoop as a whole or the cluster as a whole, one of the ways that we were able to take advantage of capabilities built into the silicon was to connect the crypto framework to the crypto acceleration that's built into the Intel Xeon processor. So today, pretty much every Xeon processor has the AES-NI, Intel Advanced Encryption Standard, new instructions built in. There's 7, let's say, primitive instructions that don't completely encapsulate the AES standard. They don't implement the AES standard, but they do execute 7 functions that when you run within that context for any kind of a symmetric key encryption that uses AES, would dramatically improve the performance. Right? So, and the way you deliver that is through a standard OpenSSL library. OpenSSL uses, any kind of a hardware acceleration underneath it, and in this case, if you were to use, just OpenSSL 1.01, for example, that version, it uses the hardware-assisted encryption. And when you do that, there are 2 things. First off, the original version of this implementation kind of had a single buffer for both the encryption and the decryption. And in many ways, it improved the decryption performance, but encryption was only slightly better. When we started to use it with both encryption and, let me go to this. So what you see here is that with the first version, when we used the Intel AES-NI, and we primarily had a single buffer for both encryption and decryption performance improved by 20 times, but encryption performance was roughly in the 5x category, which is great, which is pretty significant. But when we did multi-buffer encryption, so had multiple buffers for encryption and decryption, then the crypto performance increased to 20x. So let's put this in context, right? So if you had all the crypto functions of reading and writing a file and encrypting and decrypting every file that you read, whether it was done during the ingest phase, the map phase, the shuffle phase, or the reduce phase, that was, if you had not used the hardware-assisted encryption, we noticed there was a 20x degradation in performance. So just software encryption alone with no dependence or use or utilization of the hardware layer underneath it would indeed have slowed down your Hadoop operations by about 20 times. The fact that you can run it on an Intel Xeon, which isn't a stretch, because at this time pretty much every Hadoop cluster is also an Intel Xeon-based cluster, it means that you're simply not taking advantage of the processor capabilities that were there all along. So by tying the 2 together, we've eliminated the performance penalty. We've basically taken the Hadoop cluster, added encryption support to it, enabled it up and down the stack, so it's above MapReduce and it's below HBase, and then tied it to the hardware crypto functions in such a way that the performance penalty is completely erased. So we think that combination is exactly the way that Intel would like to work within the community. So we bring the assets that we have within the hardware layer, but we expose them through open source code up into every layer of the stack, and anybody can pretty much have access to it and build their distribution or their platform based on that code. And at the end of the day, we think that it will help stabilize the platform, secure it, and make it ready in such a way that healthcare applications, financial service application developers can all build on top of it. So how does that help you if you're an AWS developer and you want to bring a new healthcare-based application? Let's say you've got a wearable and it collects a lot of data from the individual, and there's some amount of device registration, which means you have access to the individual's identity, and you want to correlate that with an open data set that includes some amount of clinical trial data or some other kind of study, or even some corpus of text that you want to associate and mine and correlate with the individual's personal statistics or vital statistics. Well, you could have all of that data be ingested, sent to AWS, use certain instances. Again, these are the instances that would allow EC2 instances that would support HIPAA compliance, and so you can kind of look up which of those. It's the reserved instances and the dedicated instances that today would support a business associate that wants to be in HIPAA compliance. So you've uploaded the data, you've got it all in those EC2, in that EC2 cluster, and you start to use the Hadoop optimizations and enhancements that we've put up in open source, have those as patches, or even as a Hadoop deployment today using the Intel distribution. And now you're able to take advantage of the AWS infrastructure and be in compliance and consume data and do it in such a way that you're delivering a new service to end customers in a scalable, reliable way. And we think that that would really spur innovation, and we're hoping that you can, this is just a partial list, there's a lot more instance types that are out there. The ones that we find really interesting, a lot of people using are the C3 instances, they're the compute optimized instances that are enabled with AES NI. Don't bother taking pictures. You can come down to our booth. We have a well printed out sheet that lists all the EC2 instances, instance types that has AES NI support in them, and they all run Hadoop if that's what you would like them to do. So it's pretty well documented. So I'll point you to additional resources. There's definitely a lot of information on use cases and success stories at the Intel Big Data site. There's a fair bit of information specifically about the healthcare applications that we've worked with and enabled. And there's a lot more detail about Project Rhino itself on GitHub. And again, you can download a lot of the source directly from there. There's also patches that have been submitted upstream. And all of that has been packaged together in the Intel distribution for Apache Hadoop. It's an open source distribution. You could download it. You could try it out for 90 days, and there's no catch. And in addition to that, there's more resources available on compliance with HIPAA as well as other regulations at the AWS site listed there. You can go for more detail on the EC2 instance types that support this. But as I mentioned, feel free to stop by the Intel booth downstairs. It's really hard to miss, and it's right as you walk in. It's to the left, and we have a full list, and as well as there are lots of people there that'd be more than happy to talk with you about what we're doing with AWS and the partnership that we're driving forward strategically, not just for big data, but for just cloud computing in general. So with that, I will give back a bit of your time and enjoy it and use it wisely, and I'll be glad to take questions downstairs in the Intel booth area. I'll be here for another hour, so if you wanted to stop by, talk to me, that'd be a good time. Thank you for your time.